As of the last video, we basically wrapped up version 1 of our USB flashlight design. A very simple printed circuit board that has a USB connector. It plugs into a USB battery bank or any device with a USB port, and it powers an LED and allows us to use that device as a flashlight. Now, I showed you in the last video how we can export the manufacturing files, the Gerber files, and place them in a zip file that we can then send off to any manufacturer to have those boards mass produced. Now, I want to go back and make a few modifications to this design, and in doing so, show you all some of the more commonly used or sometimes more advanced features of KiCad that we haven't covered quite yet. Now, the very first of these is the ability to import third-party footprints and symbols for new components. Say we wanted to use an LED or a resistor that was an atypical format. It's a different footprint or size that's not commonly used, and KiCad therefore doesn't include it in its libraries by default. Well, then we'd have to go to the manufacturer and see if they give us some 3D models, some footprints, or some symbol files that we can import into KiCad and use in our design. And also, I've brought in an expert to help us out with this process. This is Henry. He very much enjoys watching PCB design, so he'll be accompanying us for this video. Probably just hanging out on my shoulder here or roaming around, getting closer to look at it with more detail. So what kind of parts can we use as an example to show you how to import symbols and footprints into this design? Well, let's think about what else would a flashlight need. Basically, the only real element that we're missing here, we have our light source, we have our resistor to limit the amount of current to the light source, and we have our power input. The next thing that we need is a switch, because you don't want your flashlight to be on all the time. You want to be able to turn it off and turn it on at will. So let's find a toggle switch, a switch that you press it once and it turns on, you press it again, it turns off. Just to save us some time so that we don't have to spend a whole bunch of time digging through DigiKey or Mauser trying to find a switch that fits our purposes here, I've gone ahead and picked one out for us. And you can just search for this part number right here, D6R90 F2 LFS from the manufacturer C&K. And you will find the same part. I'll also try to include this DigiKey link in the description of the video. Now, we found this part on DigiKey, but if we go to KiCad's schematic editor, where we have our circuit schematic, and we go and try to add that switch, let's go to our Place Symbols button, and then try and find what was the part number? This one right here. I'm going to copy and paste it into my symbols menu. You'll see that there are no results because this is a highly specific part that maybe was more recently announced, or maybe it's just not so common that the KiCad developers decided to include it for everyone to use or everyone to have access to as soon as they download the program. So we need to go and import this symbol ourselves so that we can then place it on our schematic and have access to it in our PCB layout. So let me show you how to do that. Going back to our DigiKey page, and most large part suppliers like DigiKey, Mauser, LCSC, they usually have some kind of field on their website that says EDA or CAD models. That is this link right here. If we click on that, we'll see that DigiKey is actually providing several different websites that supply those CAD models, those symbols, footprints, and three-dimensional models like this one here. Let's use the SnapMagic supplier because by this menu here we can see that this download will include both the schematic symbol, the footprint, and the 3D model. It's very useful to us to have all three of those. So we can go ahead and download this by clicking the Select Download Format button on the bottom of the DigiKey page. Now it'll ask you what format do you want to download those files as? Well, for the 3D model, we only have one option, the step file. That is basically universally used for three-dimensional models, whether you're 3D printing something, you're making a CAD model inside of SolidWorks or Fusion, or you're making a PCB design in KiCad. Now, for the two-dimensional models, the footprint and the symbol, they list a bunch of different CAD softwares here that you can download this library for each one of those. We want to select KiCad V6 and later because remember we're using version 9. Once we click download, you give it a second and it should really quickly download your whole zip file. Sometimes it'll give you 2 of them like this, and I'll show you why that is in just a second. So let's go over to our downloads folder and see what this looks like. So it downloaded 2 different files, 2 different zip files with the same name, except one of them has a 1 in parentheses after it. Let's extract both of those so we can see what's inside of them. I'm going to extract this one and then extract the other one. Inside of the first one, without parentheses, we have a .kicad_sim, S-Y-M, model file. We have a 3-dimensional step file. We have a license and a how to import file. We don't need the how to import file because I'm going to be telling you how to import this, so I'm just going to click on that one and delete it. It's good practice to leave the license file with your symbol library just so that whoever made these libraries for us can receive the credit that they're due for making those footprints and symbols. Sometimes that can be a really time-consuming process, so we definitely want to attribute those parts to them whenever people do spend time making those files for us and then sharing it with the community. So we can see that this folder has now 3 different files other than the license, which are the KiCad sim file, the step file, and the KiCad mod file. The sim file is the symbol. It's the abstract shape representation of our switch component. The mod file is our footprint, and the step file is our 3-dimensional model. So we will need all 3 of these. Now, there are a bunch of different ways that we can import all of these files at the same time, or different conventions for how you can store them, but I'll show you how I like to import these into my projects, just so that I can easily keep track of every single project or every single part that I use in my project, and also make it so that anyone who's working with this design in the future can just download one zip file with my entire project in it, and they don't have to go out and find all of these models again. They'll all be packaged self-contained inside of our KiCad project folder. So to do that, the first thing that I'm going to do is start by changing the names of every one of these files except for the license to be exactly the same. You really don't have to do this, but again, I find that it just makes it easier for me to recognize what files correspond to what parts, because if I ever don't remember, I can just copy and paste the name of this file into Google or into DigiKey, and then it'll bring up the part immediately, and I'll realize that this is my switch. So if I go back out now, you'll see that I have this directory, but then the question is, what was the second directory that we downloaded? What was this one with the 1 symbol, or 1 number? This one only has the step file, the 3D model in it. The reason that DigiKey did this is because sometimes the manufacturer of these parts include a step file, a 3D model of their components whenever they add them to DigiKey, and other times third parties, just random people who want to contribute to this electronics design community will model their own step files and upload them to DigiKey for use as well, or upload them to SnapMagic in this case as well. For us, we now have duplicates though, so we don't even need that second one. We can delete that altogether. We only need this main folder with our step file, our symbol file, and our mod or footprint file. Now what we're going to do next is let's go to the directory of our KiCad project, which in my case was on my desktop inside of the USB flashlight folder, and now I can see all of my different KiCad project files. I'm going to make a new folder here. Right in that home directory, I'm going to call it part, oops, going to call it part library, part underscore library, just because with computers it's standard practice to not include spaces in the names of your folders. I'll delete this empty new folder that I accidentally created. Now the part library folder, what we want to do is we want to put all of the downloaded library files for all of our different parts that we might be using inside of this part library folder. So I will copy this D6R90 F2 LFS folder that we modified such that all the library files in here have the same name. I'll copy that entire directory by right-clicking, clicking on copy, and then pasting it into this menu right here, or into that part library folder. Now, why are we doing it like this? Why not just copying the contents of that library into this part library folder? Well, sometimes you'll wind up importing hundreds of different parts into a very large and complex design. So inside of your part library folder, you want to be able to easily go between different part folders and look at the different files corresponding to each one of them. You do not want to mix those up. So again, this is all convention, but I find that organizing them like this, where you have a folder for the part number of each one of the custom parts that you're using, makes it really easy to know exactly what parts you're using. So now that we've created, or now that we've imported the files into the KiCad project directory, we actually need to go in and manually tell KiCad where these files are so that it knows how to find them. So let's go back to our KiCad main menu, which is this page right here. You'll remember that I told you that the symbol editor and the footprint editor pages here are used exclusively for importing new part files or for modifying old part files. Let's actually do that now. Let's click on this symbol right here for the footprint editor. It makes our lives a little bit easier to start with the footprint editor, and I'll show you exactly why in just a second. Inside of our footprint editor, we can see all of the different libraries on this left-hand panel that KiCad comes pre-built with. There are tons of them in here. I think it was like 15,000 different parts. And now you can spend some time going through these and looking at what each one actually looks like. These are all the different battery holders. There are different connectors that we can use. Tons of things come pre-installed in KiCad, so before we go out and select a part willy-nilly just off of DigiKey, it's often very useful to search for one in KiCad's libraries. But the entire purpose of this little section of our tutorial is to show you how to import new parts if you so need to. So we're going to ignore all of these ones that are already included for now. Instead, I'm going to go up to File, New Library. Now, pay attention to this menu that pops up. It's asking me to choose the library table that I want to add my new library to. If I pick global, then all of the part files that KiCad creates, or all of the references that it adds to itself to know where the libraries are going to be stored locally on my computer. They're going to be in various directories, whether in documents or app data, so on and so forth, which works fine if I'm the only one working on these projects. But if I wanted to share my KiCad project with someone else for them to work on it, then they might not have those files on their computer. So for this reason, we want to select project instead. This makes the entire project self-contained. KiCad will only use the files that are inside of its own directory. So I'll select project and I'll click OK. KiCad will now ask us where do we want to save the new library that we're creating. I like to put that inside of the same part library folder that we just created. I'm going to leave the default name as library.pretty. .pretty is just KiCad's file extension for library files, for specifically footprint library files. I'm going to click Save to create that file there. And now you'll see that inside of this panel on the left, you'll have a new row that just says library. Now, it might not automatically go up to the top here for you. If it doesn't, then you'll have to go down and find it wherever it may be. These are alphabetized, so it'll be somewhere around here. You would right click on it and then click on Pin Library. All of your pinned libraries go right up to the top here, so it's really easy to find them. And if you use the same name for all of your libraries in different KiCad projects, they start automatically going up to the top here. That's why I didn't even have to manually pin mine. It just immediately was automatically pinned and placed up at the very top of my libraries menu. Now, if we click on the little drop-down arrow by that library row, we'll see that there's nothing in it. It's an empty library as of right now. So we want to take the footprint file for that switch that we just downloaded and put inside of our project directory, and we want to import it into KiCad here. So I will right-click on my library row and click on Import Footprint. And then I will go into this switch directory with the part number of the switch we just downloaded. And then the only file it should let us select is the KiCad mod file, because that is a KiCad footprint file extension. So I'll double click on that, and you'll see it'll open up the footprint file for our that switch that we just saw on DigiKey. It's exactly this part right here. So this is great. We are almost there. We've almost imported the files exactly as we need them. Now, while we're at this stage, we can customize our footprint a little bit. For instance, I don't want my reference designator to be placed up here. I want it to be placed maybe over here off to the side. Once we have the footprint looking exactly the way we want it, there are a couple of things that we need to modify before we can actually save this and move on. If you double click on the empty space that is anywhere around this footprint, you'll open the footprint properties menu, and it should look something like this. Let's change the value to be exactly the same name as the footprint name. I don't really want this SW prefix. So I'm just going to change those so that they match. I also want to tell KiCad where it can find the step file, the 3D model for this component, so that later on, whenever we create our 3D render of our printed circuit board, the switch will show up on there as we want it to. So I'll click on the 3D Models tab. You'll see a three-dimensional representation of what the PCB footprint will look like, but you'll see that there's no 3D model there yet. For this, we can click on the little plus icon underneath this empty table here, and you'll see a row will show up. We can click on the little folder icon next to that row, and then it should open automatically to the same folder where we just imported our footprint. If it doesn't, then just go to your part library folder, find the folder where we copy and pasted all of our switch custom library elements in there, and then double click on the step file. Now you'll see that it imported, but it didn't import correctly. Now it's sort of parallel to the printed circuit board instead of being mounted at a right angle on top of it. So we can just play around with the different positioning offsets here to make it appear correctly inside of our 3D render. It looks like our x-axis rotation needs to be increased to 90 degrees, but other than that, this looks spot on. So it's just that x-axis. And this is perfect. So now KiCad knows where to find our 3D model too. And we can just click OK. And now make sure that you click on Control-S to save this so that we don't lose our progress. Whenever you do that, it'll ask, what library do you want to save this in? We want to save this in our pinned library, the one that we created. So I will select that one and click on OK. And now you'll see that our switch part number appears inside of our custom created KiCad symbol library right over here, our footprint library. And now we can actually move on to actually creating the symbol that corresponds to this footprint, which we already downloaded the symbol, but again, we need to show KiCad where to find that file so that we don't have to go in and manually draw out a symbol for this. So we can close out of the footprint editor. We don't need this again since that's the only footprint we'll be adding to our design. And now go back to the KiCad main menu, and we will be using the symbol editor right here. And now basically the same deal. We have to repeat the entire process but with a symbol instead of a footprint. So I'm going to go to File, New Library, select Project instead of Global for our library table, go into the Part Library folder, and now I'm going to name it just library.kicad_sim. And I will click Save. And you'll see that our library appears in this column on the left. Now we can pin that to the top if it isn't already, just by finding it and then right-clicking on it and clicking on Pin Library. But again, if you've already done this for any project that you've worked on in KiCad on your computer, it'll automatically pin that if you create a library with the same name. So now let's import our actual switch symbol. And to do that, we'd right-click on Library, click on Import Symbol, and then go into the folder with our switch part number. Inside of here, it'll only let you select the KiCad_sim file, which is the correct symbol, the schematic symbol 2D model. So I'll double-click on that, and you'll see a bunch of text sort of overlapping each other. Now, by default, I don't know why this is, but a ton of different manufacturers and design companies make footprints or symbols in KiCad that are just really jumbled and have things all over the place. So we can go in and clean this up before we actually want to use it. Double-click on the white space around this before you actually click and drag anything around. And you'll see inside of the library symbol properties menu that appears, we have a bunch of different fields that we don't actually care about all that much. We don't care about the standard, so I'll click on that row and click on delete. I'll delete the minimum package height row. I'll delete the manufacturer because only one manufacturer makes a part with this part number. And I don't really care what the part revision date was, so I'll delete that one too. Now, the other thing that we need to change in here is we need to make the footprint reference the footprint that we just imported in the footprint editor. So I'll click on the little book icon in that row and scroll all the way up to our pinned library, and you should see the footprint that we just imported. So if I double click on that one, it'll replace that row in this table with library, colon, and the name of your footprint. If you called your library something else other than just library, that text will be here. This is the name of the library and then the name of the part within that library after the colon. Now, that is all we have to do inside of this menu. We don't need to associate the 3D model because we already did that in the footprint, not in the symbol. So we can click on OK, and you'll see that because we deleted a bunch of those text fields, some of our text here has gone away. This is a little bit easier to read. Now, it still has this green text, green for me. Again, this might not look exactly the same for you because there are different themes for different installations of KiCad. I'm going to click and drag on this text and just place it somewhere down here where it's out of the way. This text is not actually going to show up on our schematic. It's just on a hidden layer in case we want to know which library each part belongs to whenever we're viewing the schematic. So I'm just going to leave it there. I don't really care that it shows up in this symbol editor menu. I'm going to tidy this up just a little bit. I want this label, the value field for my switch, to actually be center aligned with the switch symbol, which right now it's aligned to the left. If you select that field and then go over to the horizontal justification row in your properties menu on the left over here, we can switch this to center. And now you'll see that the anchor point, that little plus sign, is in the middle. I can click and drag that wherever I want it. I'll do the same thing with the reference designator up here. I'll make it center justified and then put it in the center right above the switch. Now another thing that I'll change, and this is again just a convention thing, typically for switches the reference designator starts with SW rather than just S. So I'm going to modify this to be SW. Remember, the reference designator is the symbol or the very short text value that shows up on your schematic and on your actual silk screen on your PCB to indicate what part goes where. So we want this to be something that's easily readable and something that we'll recognize as soon as we glance at it. So if I see SW, I'll immediately recognize this as a switch. And KiCad will, every time we place one of these switches in our actual schematic, it'll add a number after it. So the first switch that we place will be SW1, and then the second switch we place will be SW2 if we were to use multiple. So now I'm actually done in this menu. I'll click OK, and we are just about good to go. Now, you may object and say that, hold on a second, we actually have a couple of pins stacked on top of each other here. You can see that pins 1 and 2 are both on top of each other on this side of the switch. Pins 3 and 4 are stacked on top of each other on the other side of the switch. This is intentional. If you want to see exactly why, I'm going to quickly go back to our footprint editor just because I want to show you why the footprint for that symbol is designed that way. You don't have to do this if you are following along. You can just look at my screen and it should serve as an example. So our switch, you know that most switches or buttons just have one input, one output. This switch, on the other hand, has 4 pins. So what it's actually doing is it's bridging together 2 pins as the input. So we can use either one of these, pins 1 and 2 for the input, and pins 3 and 4 are both the output. So I could just connect one of them, like I could connect an input to pin 1 and an output to pin 3, or I could connect to 1 and 2 for the input and pins 3 and 4 for the output. It doesn't matter. So the reason that they're laying on top of each other that way in our symbol editor is because the designer of this symbol wanted to make it so that if we're connecting one input to the switch, we don't want to have to connect it to 2 different pins individually. We can just connect it to this one, and because they're overlapping, it'll automatically connect to 2 different pins. So it's just a clever little trick that we can do. And now we can press Control S, and our symbol should show up in the library that we created. So this is the entire process to import a symbol and a footprint inside of KiCad. Next, we will actually go in and add this to our schematic and modify our design so it actually has that switch on the PCB. But before we do that, just note that this is exactly the same process if, for instance, we wanted to use that switch that C&K makes, but suppose DigiKey didn't provide the models for us. Suppose we actually wanted to design a new symbol ourselves. We could do that here just as easily, just by right-clicking on Library, going to New Symbol rather than Import Symbol, giving it a whole bunch of different parameters, and then you can use the shape tools on the right-hand side to draw out these symbols manually. So even if you're trying to import a part that is not widely used on the market and nobody has already made a symbol or a footprint for it yet, you can look at the datasheet of that part and then draw those symbols and footprints yourselves. You're never completely out of luck there. Even absolute worst case, if you have the component but you don't have the datasheet for it, you can use a set of calipers or a very tiny ruler to measure the distance between each pin to design the footprint. So that would be the process for designing a new symbol inside of KiCad. We're not going to cover that here just because it does take a whole lot of time, and like I said, more often than not, for any mass-produced component that you want to use in your design, you'll already be able to find the symbol and footprint somewhere out there, whether that's on DigiKey or SnapMagic, or there are a couple of other providers like Symaxis and SnapEDA. No, that's the parent company of SnapMagic, but you get the gist. So now let's actually go and place this switch on our actual schematic. I'm going to close out of the symbol editor because we don't need this anymore. And we go back to our schematic that I already have open over here. And, oops, I accidentally clicked on the place symbols menu, which we're going to do, but not yet. I'm going to click on escape so that I'm not automatically placing a symbol. And now I want to interrupt the circuit with the LED and place the switch in between. I want to interrupt the VBus connection right over here. So what I'm going to do is I'm going to click and drag to select everything on the right hand side of my diagram up to the LED, and then I'm going to drag them out further to the right. And I can click out of them to deselect. I'll delete this line from VBus to the LED by clicking on it to select it and pressing delete. And now let's place our switch. I'll click on the place symbols icon up in the top right, and then inside of our pinned library you'll see the part that we just added. And if I double click on that, we'll be able to place our switch symbol. I'll place that right in between the LED and the USB connector, and then draw a connection from VBus to the input of the switch, draw another connection from the output of the switch to the LED, and we are done with our schematic. I'm going to press Ctrl S to save this, and now let's apply those changes to our actual PCB layout. So I will click this button up here to switch to PCB editor. You'll see that this does not have the switch in it yet because we have not updated from the schematic, which we can do with this little button up in the top. Update PCB from schematic, or press your F8 key on your keyboard. If we assigned our footprint correctly, this should show us no errors. We press update PCB and close, and now we are dragging around the switch. And this is a very big switch. It's about the size of our entire PCB so far. So we're going to have to move some things around a little bit. I'm going to first I'm going to press Ctrl B to unfill the entire copper zone that we added for ground here. And now let's delete the traces for the resistor and the, do I need to do that? I don't need to, but it might make it easier to rearrange things afterwards. I'm going to delete the traces from the diode from the LED to the resistor and from the USB connector to the LED. To do that all in one shot, I'll hold Control, click once on this trace over here, click on this other trace down here, and then I'll press U 2 times to select both of the entire traces. Now I can press delete and get rid of all of it. Alright, now let's shift our LED and our resistor down a bit. To do this, actually let's double check that this is going where we want it to go by looking at our schematic. So the switch should be the first thing that the VBus pin on the USB connector is connected to. So we want the switch, the input terminals of the switch, which are 1 and 2 over here, to be close to VBus. So I'm just going to move the resistor and the LED off of the board for now, and we'll come back to it in a second. I'm going to put the switch right up next to our USB connector, like so. And I'm going to put our LED and our resistor back right next to the switch. So now let's see if this looks correct. VBus from the USB connector goes to pin 1 on the switch. Pin 4 on the switch goes to pin 2 on the LED. Pin 1 on the LED connects to the resistor, and then the resistor connects to ground. That looks great. There is one small change that we can make to optimize this a little bit, which is that since both pins 1 and 2 are VBus, are inputs to the switch, we want to flip this around so VBus is facing closer to the USB connector. Same with pins 3 and 4 being outputs. We want both of them facing the LED. So I can just click on that to select it, and then tap on the R button to rotate it until that change is made, like so. Now, in doing so, I've wound up accidentally making the courtyard of my switch intersect with that of the USB. So I'll shift that down a little bit, and I'll also shift down my LED and my resistor, and now all of my traces should be very short whenever I actually start drawing them together. But you'll notice in moving all of our components around and adding things like this, the outline of our board and our copper zone no longer encompass the entire or all of the components in our design. So we'll need to shift those down a bit. Now I could click on this line, the right side line of the edge of the board on the edge cuts layer that we drew before, and I could drag that, but that becomes really imprecise really quickly, because then it's very hard to make sure that this is at a perfect 90-degree angle to this other line on the bottom. So I'm going to press Ctrl Z to undo that. What I'll do instead, here's another slightly more advanced trick that you will use a lot whenever you're designing PCBs. I'm going to select this arc on the bottom corner, and now I'm going to hold Control and select this line on the right hand side as well. And then still holding Control, I'm going to select the arc in the top right. Now I want to shift all of these over past the diode over here. That's about maybe let's say 14 millimeters. So what I can do to keep them all exactly in the same y coordinates, the same vertical coordinates that they are right now, but shift them over horizontally, is I can press the Shift M shortcut. And this gives me a Move Item menu. I can type in the 15 millimeters that I want to move my outline by, and then press OK in the X field, and it will have shifted over. Just like that. That's perfectly in the same y coordinate as it was before. It's just horizontally moved down. So now what I can do is just extend the top line from the previous version of our board, extend this end out to meet that other end. And I don't have to worry so much about keeping this in exactly the same y coordinates, because it should automatically snap whenever I get close to the edge of this arc, like that. And I'll do the same with the bottom line. And it should snap on like that. Sometimes it's easier when you're zoomed out a little bit, actually. And now we need to extend our ground zone. This copper zone that we added for all of our ground connections, we need to extend it out all the way to the edge of this board here. So I'll click on the outline over here, and then click on this little circular dot between the two corners. And that, if I drag it, should allow me to just extend the rectangle out to the edge. Now you may be wondering, why does this work if the copper zone overshoots the actual edge of the board? Well, remember, when we defined our copper zone in an earlier video, we gave it a clearance of 0.5 millimeters. So KiCad knows to only fill in this copper zone whenever it's within 0.5 millimeters of the outline of the board, of the edge of that board. So now if we press B, our ground layer fills in across the entire board, and everything that should be connected to ground, like this resistor pad here, the shielding pads on our USB connector, and the actual ground pin on our USB connector, they are all grounded. So this is perfect. Now we need to just go back and redraw all of the traces. To do that, I'm going to once again use Control B to unfill that copper zone. I'm going to select 0.2 millimeters for my track width, and the 0.7 by 0.3 millimeters for vias, even though I don't think I'll need any vias for this, just in case I do. And now I'll start drawing my traces, which I can do by hovering over the first pad I want to draw a trace from, pressing X, and then connecting everything together. You'll see that it says that pins 1 and 2 should be connected together based on this thin blue line between the two of them. And then pins 3 and 4 should be connected together because there's a blue net line between them. And then there is a connection from pin 4 to pin 2 of the LED, from the cathode or pin 1 of the LED to the resistor. And then we don't have to worry about the ground connections because whenever we press B again, like so, and it fills in all the grounds, those blue net lines disappear because KiCad realizes that our copper zone was, it fills in all of those ground connections for us, so we don't need to draw traces. And just like that, our board is now done with a new custom imported switch into it. And we can go to View, 3D Viewer, and you'll see what this looks like with the switch on it. Again, the USB connector isn't rendering for some reason, but now we actually know what the process is like for importing a three-dimensional file for this. So now we have all of the knowledge we need to be able and go and find the part number for this USB connector, find it on DigiKey, download the 3D step file, and import it into KiCad so it shows up in this render. I'm actually going to do that really quick just because we now know how, and we can make this 3D render perfect for our purposes. So I'm going to go over to my schematic, double click on the USB connector, a symbol, just because I want to pull this manufacturer part number from it. I'll copy that, close out of this, and then go back to DigiKey. Now if I paste in the part number of that USB connector, it'll take me right to this part. And I can go to the CAD models. I don't need the symbol or the footprint because I already have those. KiCad comes included with those. I only need the step file, the 3D model. So I'm not going to download from Ultra Librarian or SnapMagic because those include all of the files while I just need the step file. I'm just going to use the manufacturer provided one right up here. If I click on that, it'll download. I can pull my downloads down here so you can see what I'm doing. I will extract this. I will change the folder name so that it doesn't have the STP in it because I just want this to be the part number of that USB connector. And the contents are already perfect. Now I'll copy this entire folder and paste it into my part library directory, which just so you remember where that is, it's inside of our KiCad project folder, inside of the part library folder that we made, and we paste it right there. So now KiCad has our 3D model. How do we tell it where to find it? Well, since that file is, or since the symbol and the footprint that we already used in KiCad, they are part of KiCad's built-in custom libraries, we can't modify that and add a 3D model after the fact to the entire library, but we can add it for this part in our design in particular. So for this, we can just double-click on the USB connector on our actual PCB layout in the PCB Editor tab, go over to 3D models, and we can change this broken link that is the reason that our USB connector wasn't showing up in the render. We can instead point it to the step file that we just downloaded right here. And again, it shows up, but it's oriented a little weird. So let's play around with the offsets to make it so that it is in the correct arrangement. So X offset needs to be positive 90. Z offset needs to be, yeah, positive 90 as well. And then we need to shift it up a bit because it's sort of phasing through the board right now. To do that, you'll go down to your Z offset in the actual offsets category, and it looks like we can just shift it up by, oh wait, never mind. This is supposed to be, there is no actual PCB past this line right down here. So the connector is actually supposed to be inset part ways and sort of level with our board. That's why, well, I'll show you in a second. If we click on OK and save this, that's why we cut off the PCB way up here, even though the USB connector itself extends all the way out to the edge of this purple courtyard line over here. So now, if we go to View and then 3D Viewer, our USB connector shows up. And this is our new version 2 USB flashlight. To denote that we made those changes, remember, we can go into our this little metadata block. We can update to the new current date. I can call this version 2.0 or maybe 1.5 or something like that, up to you. And I'll call it USB flashlight with switch. Okay. I'll save this, and I will go back and modify the schematic to also have those updates. Current date, version 2.0, and USB flashlight with switch. Okay. And now you can follow the instructions that we talked about in the last video to export your Gerber files, send them to a manufacturer, and get this ordered if you so choose.